one of the most fantastic tools that we have, that's the hand. To be able to replace a hand or restore some of that functionality, it's a very, very difficult task.
The prosthesis is a robot, and it is essential to replicate on the prosthesis the same behavior observed in normal people.
One major problem has been to, in a reliable way, transfer information back and forth, especially for the amputee. I think we have solved that now.
In Lifehand 2, the main goal was to use the neural interface to record the intention of motion and to control the hand, and then to give back the feedback, the perception of the interaction with the object.
Our team and the work with Dr. Rika Bronnemer has been on using osseointegration.
We put a piece of metal that happened to be titanium into the skeleton, let it be anchored in the skeleton, and then it's protruding through the skin. Normally there will be some kind of rejection mechanism by the immune system. But for some reason, the cells in the body like titanium, and the cells start to incorporate with the titanium.
Once we have the connection done and they have healed from the surgery, they take this home. And every time they connect the prosthesis, they get a mechanical connection, but they also have an electrical connection with the electrode that is in the muscle. The way this hand knows what to do is because Magnus is sending a signal from his brain to the nerves, to the electrodes that are implanted on his arm, and those signals travel through the implant to the hand, and then the hand activates.
Observing people is one of the fundamental features of designing new robots, especially if we want to think of robots conceived to live with people. So the idea is to observe people and, if possible, record motion of people and then replicate them on robots.
No, we are not terminators yet. Although what is interesting with these kind of technologies is that you can add function that we do not have. There are sensors out there that we can use that can feel things that you can't do with your normal body. You have infrared sensors, for instance, just to take an example. So what we can do today is that we can create spare parts that will have some things that are better than the original.
The next step is improve the sensor capabilities of the hand and improve the intelligence on board the hand in order to make the hand more and more autonomous in performing the task.
The boundary between man and machine is there, but we are slowly finding ways of bypassing the hurdles.